Okay, my friends watching, hopefully you got that problem because, yeah, I ran out of storage space. We're good to go now, I think, for the rest of the time. So number 16, we can find what the K value is. Did you now find the K value?
Oh, no.
Go ahead and do it. So you're given the delta G, or enough information to find delta G, and you know a relationship between delta G and K. So you can solve for the K.
What is...
These are all on this paper multiple choice problems, so just get an answer and then look
Without
and
a
see.
calculator?
You got that. It is negative RT. Yeah, my cursor is there.
Without a calculator?
Yeah, we can use a calculator for this one. Huh. Calculator's over full? Really? That's strange. I've never heard that with those calculators before. What's the sign on delta G?
Negative.
It is a negative delta G. What does that mean about the K value? If delta G is negative, it means the reaction is spontaneous. K what? If it's a spontaneous reaction, that means there's going to be more products than reactants at equilibrium. K is going to be greater than 1. So that means that you can throw out 3 of the answers right now.
Oh, wow.
Because B is no good, E is no good, and C is no good. Because all of those are either 1 or less than 1. K has to be greater than 1. Miss Lena?
Found it. How does that work? Like, how do you know if K is bigger or less than A?
Great question.
Like, I never...
K. If K is greater than 1, that means that the reaction favors the products in equilibrium, because K is a ratio, right? And so you got more products. All right. Now, what would the natural log of K be if it was greater than 1? Positive or negative? Always? So if K is 1.01, do it on your calculator. What's the natural log of 1.01? No.
Yeah.
Does it say 0? How about 1.1? Too close to 1.
3.
Yeah.
No, it's 0.009.
Okay, positive or negative? Right. When you take the natural log of something, you're saying e to what power equals that number, or not the 1, but e to that power equals the k. So as long as k is greater than 1, the natural log of k is always going to be positive. Okay, and let it look up here. So if k is greater than 1, this term is positive, t is always positive because it's Kelvin. R is always positive. So a negative of all these positive numbers will make a negative delta G. You see what I'm saying?
Yeah.
So no matter what k is, as long as it's greater than 1 and it favors the products, delta G is going to be negative. And the vice versa as well. As long as delta G is negative, you know k is going to be greater than 1. Yeah?
So in equilibrium, if thing is so spontaneous, then it favors the product.
Yes.
And if it's not, it favors the reactant.
Right.
And K would be less than.
Yes. Because k is less than 1. Put it into your calculator. 0.999. Take the natural log of it. It's going to give you a negative number. So that number is going to be negative, and a negative of a negative will always give you a positive number. Okay? Yes, ma'am? Okay. So for number 16, we have, did you get an answer for that one now? It should be A.
A.
I got A.
Negative RT ln of K? Yeah.
Wait, is this product minus reactant?
Yeah.
Yes, product minus
Okay.
reactant.
So I just realized afterwards.
Oh, so you hit the positive delta G. Yeah. That'd be
Is
negative.
that changing?
Yeah. Big time.
Sure.
Okay, now we need to talk about what do we do if we have to manipulate an equation, what happens to the K value? This is going to have the feel of Hess's law. You know how we had delta H's, and if you multiply through by 2, then you got to double the delta H? Well, now we're going to have a reaction, a chemical equation, and the K value or expression. And so how does that change? Well, let's see. If we have this chemical equation, A plus B yields C plus D, and it comes to equilibrium, the K value is the concentration of C times the concentration of D. It's the product concentration over the reactant. When we did the chapter on thermodynamics, we were using the pressures. If you remember that, it was all gases, and so we had pressure of C and D divided by the pressure of A and B. The same concept applies to concentration, though, too. If you have solutions, or even talk about the concentration of the gas. Solids and liquids will stay out of the K expression. It just won't go in. Only gases and aqueous do. If we're going to call this equation 1 here. So if we take equation 1 and we multiply through by 2.
We just raised it.
Yeah, to the second.
Yes. So these terms are all going to be squared. It's going to be, they use a different color. C squared times D squared over A squared times B squared. Yeah? Can we simplify that mathematically? If you got squared times squared over squared times squared, couldn't we just do this thing and square the whole thing?
Why would you do that in the first place?
Because,
Please do like
what does this look like?
the K.
Yeah, but why would you like multiply everything by 2 when it's at?
Oh, why would you do that? Oh, because sometimes we'll have to when we have to do Hess's law. When you have to come up with a resulting overall equation, you might have to multiply through by 2. I see what you're saying. So, yeah, this thing is the same as that. So which is K1. So when you have to multiply an equation through by 2, you don't multiply the K by 2. You raise it to the power of 2. It's an exponential relationship, not just a additive or a multiplicative. So if I had to divide this thing through by 2, what would I do with the K?
Raise it to that.
Raise it to the half power, take the square root. Yeah. You okay with that?
Yeah.
All right. So what about if we have to take equation 1 and turn it around? Take C plus D and put it there and A plus B over there. You're on to me. That's right. It would be the inverse. Here's why. Because now the K of this thing would be that over that, because it's always products over reactants. So it's going to be A, B. Boy, I can barely get this uncovered. Brandon's got the answer. Which is 1 over K1. It's the inverse of the first K. If you have to turn an equation around, and it's like you're raising it to the negative 1 power. Anybody have any questions about that? Okay, so we're going to do some Hess's law kinds of problems with equilibrium. Would you go in your packet to number 2? Try number 2.
Packet.
Are we gonna be able to start the homework tonight?
Yes, very much so. You'll be able to do quite a bit of the homework tonight.
Hopefully it's under.
Wait, is it
I know some of you like let it just chug them. I totally get it. You think, okay, to say today's December 18th, the quiz is January what?
That's
6th? Like I'm going to start homework tonight, right? But wow, you'll be so happy that you do. You're not motivated. I totally get it. What, Sophie?
You can have more holiday time.
That's right.
Yeah.
Save more time for the exam review packet. And that's kind of cruel and unusual, but I think that you'll be very happy later if you start the homework now.
But if we look at the opportunity comes.
Start it on Saturday.
I actually do better if I don't start on the homework early.
Wrong.
No, that's just me though.
So like, wrong.
The cabinet
Can you go on to the next slide?
Sure.
But that's just me.
So, since those equations are in equilibrium,
Yeah.
and they can basically go in any way, how would it make a difference what's first, the C and the D or the A?
Okay, great question. So if I put A and B together, it is going to start producing C and D. And over time, remember, the reaction is reversible, so even as it's going this way, there may be C and D combining and going back that way, to some extent. The rate of that direction will be greater until it gets to equilibrium, and then the rate of both directions is the same. That's what equilibrium is. You okay with that? So since it's a reversible reaction, it can go in that direction and it can go in that direction. If I only start with A and B, it's going to go in that direction overall until it gets to equilibrium and then it stops. And it's going to stop when I still have some A and B present and there will be C and D present too. Would you respond a little bit at least? Equilibrium. You got some of that and the reaction is stopped. Let's say that the K value for that equilibrium is 10. That means that the ratio of those concentrations to those concentrations is 10 to 1. Now, if I, in a different container, take some C and D, and I put those together, those are going to react and go that way because there's none of these, so it has to go that way. It's going to turn out that there's still going to be 10 times as much of that as that. And their K value will be 1 over 10. You see how that works?
I just learned
But now it makes more sense, more clear. Okay, all right.
So if K is negative, then that means that there's going to be more reactants.
K is
in
never
products.
negative.
Oh, I mean like.
Is
No.
less than 1?
Yeah, less than 1.
Okay.
And then if it's going to be like, it's going to be positive if it's like more products and everything. If there's more products and reactants, it's going to be greater than 1, right? So if they're equal,
Yes.
then would it just be like 1 then?
Uh-huh.
Or- okay.
Yeah. I've never seen an equation where K equals 1. I mean,
Okay.
how likely? I'm sure you can take an equation and change the conditions just right so that the K equals 1. But then you'd have exactly the same concentration of both. All right. So now, let's try number 2. I'd like to do this one with you, and then I'll ask you to try numbers 3 and 4. But let's do number 2 together. So we have A plus 2B yields C. That has a K value. And then we have C yields D plus C. That has a K value. They're different equations, so there's 2 different K values. Add those 2 together, we're going to get A plus 2B yields. Now C is an intermediate here, it looks like, in this whole process. So if you combine A and 2B, you're going to wind up with D and E because it makes C and C makes that. So you just wind up making that. Okay, now K1, for this first equation, was concentration of C over the concentration of A times B squared. Then K2 was concentration of D and E over the concentration of C. After adding these 2 equations together, I'll be right there, we could write the equilibrium expression for this one too. What would it look like? Now they call it in this reaction, or in this problem, they call it Kc. Why do they call it Kc? I'll tell you soon. It would be D times E. Now I'm just doing this based on what the reactants and the products are. I got 1 D and 1 E, so they're on top, and then I got an A and 2 B's on the bottom. That would be the K value of that. 1 second, Barun. Lena, you're first. Okay, Barun?
So it's like when you add the things using Hess's law, then you multiply the K's.
That's what I was thinking.
Exactly. My next question was, okay, so if this is the resulting equilibrium constant for this new reaction, how did you take K1 and K2? Because the answer is expressed in terms of K1 and K2. So what had to be done to K1 and K2 to get that?
Multiply.
You have to multiply.
C's times
Yep. Yes, ma'am.
But you just also look at the reaction equation. Like A plus 2B is.
This?
Yeah.
Yes, but which answer do you choose? Because it's expressed in terms of K1 and K2. So what I want you to see is when you have to add 2 equations together, you multiply their K's to get the final K value. For Hess's law, when it was delta H, you added the delta H's. For K's, though, you have to multiply them. You going to keep those straight? I think you will. It's not that bad to keep
Wasn't
straight.
that one of the the problems if it passes all like that or something with delta G and then like you said, but don't do it now because we're gonna do it later. It was like something like that.
I might have. I think now was later.
Number 4.
Ready? Let's try number 3. Do number 3.
There's more.
Yes,
I
sir.
have handouts. Or not.
Oh, I'll show the audience number 3.
So. Should be good.
Well, let's just leave it
Or-
for a few
okay.
seconds. I mean, Amberth is a slow reader.
No. Okay. Well, tiny little buttons.
Pause it, Amberth.
Thanks.
Can you do number 3 without a calculator? I request that you do.
No.
Those numbers look scary, but they're not.
No.
I see you're working on number 4, aren't you, Nick? Too fast.
Fast for life.
Ah, gosh.
Oh. Ooh. Oh. I see. what
So
you did
let's
there.
see. Looks like we have to. What do we have to do with the first equation there?
Inverse.
Inverse.
We have to invert it and do something else. We have to divide it by 2.
Yeah.
Yes.
Yay, got that.
So it's going to be reaction 1 times negative 1/2.
Why would you do it?
Because we can only have one SO2 in the overall reaction, and equation 1 has 2 SO2s.
Also the SO3.
Yes. Shanok, do you see that?
Wait.
They give you 2 equations, and then they ask you to manipulate those to find a third equation.
Oh, yeah.
Okay, so you only need one SO2. Artea?
Could you write another marker?
Red is not as visible? Sure.
I like the
Back.
background. Except it's not.
Reaction 1 times negative 1/2
Go like that.
looks like this. So I'm going to turn that thing around. It's going to be 1 SO2 plus 1/2 of an O2 yields 1 SO3. Thank you, Kathy. And then the K, okay, my friends, what are we going to do with that K? Right. You have to turn the reaction around, which means you have to invert the K. And then we have to divide by 2, which means you have to take the square root.
Wow.
So take 225, invert it, which is 1 over 225.
15.
Then take the square root of it. Square root of 225, 15.
Math off.
Math.
How
No,
about
I
that?
said first.
Why did you say
Oh, because we had to divide the coefficients by 2. So that means you take the square root of the K value. Don't divide it by 2, take the square root of it with K's. And then reaction 2, do we have to do anything with reaction 2? We have to divide by 2. I'm going to say times 1/2. So, where it's going to be 1 NO2 yields 1 NO plus 1/2 O2. Oh, that's good. We want to cancel out the O2s. So that cancels out, right? And since we divided through by 2, what do we have to do to the K value? Take the square root. And this original K was 64, so the square root is 8. So now we're going to add these 2 together. And 1/2 is gone, 1/2 O2 is gone, so we have our overall equation, SO2 plus NO2, NO plus SO3. And
What's 8?
the K value is
D.
8/15. Should I?
Why do we take the inverse of the first reaction?
Because we had to turn it around. And if you have to take a reaction and turn it around, then we take the inverse of it, like I showed you here. See how this one had a certain K value? When I take those and turn them around, is the inverse of the K value.
Oh, yeah.
Okay?
Yeah.
That was that one.
Shouldn't it be negative?
No, we don't multiply by -1. We raise it to the -1 power, which means inverse. It's still positive. K is never negative. So the answer here is K is 8 over 15,
They're more than half.
and it's just over half. Yeah, so you can find the answer there on your paper. How do you like that one? I like doing these problems. They're pretty neat.
I like Hess's law.
I always did too. Hess's law. It works. Yeah.
They only get easier, right?
Yes. We start hard and then go easy.
That makes sense. Why can't we
Would you try number 4?
They can.
It'll be easier. Try it. I know you do.
The K ones, the K values are not given.
Yes.
Like,
Oh, thank you,
do
Bruce.
that? We don't.
like,
The what?
There's no numerical value to it.
Right. Just have to give the answer in terms of the case. Yep.
By the way, if
Focus in.
the-
We got that one?
I thought you said it's gonna be easier.
This one, number 4? It's easy.
Oh yeah.
By the way, my friends, I love this worksheet because a lot of these questions were taken from very old resources. So old that a typewriter was used to write them. Look at the font like in number 4.
Yeah.
Isn't that a great font? Do any of you have typewriters at home still?
My violin
Did you
teacher
used to
has
have
one.
Man, it
My dad has like.
is so remarkable how good you had to be at typing when you didn't have a backspace button, right?
Whoa.
I mean, it was typewriter or typists, they were skilled. Yeah, and
It'd be so scary.
I know.
I would get fired
Yep.
the first time.
Lots of whiteout, you know, and yeah, it was. Yes,
Are you gonna put the solutions on the?
I did not put them on yet. Yes, I will. I forgot last chapter too. Sorry, and I forgot them again. Everything else is on that line. I know. All right, did you get number 4?
Wait,
Yeah.
Bruno, not everyone can do everything next week. Got it.
Wait, why is this like so hard?
I was distracted.
You need 4 NH3s on the left. You already have them, so don't do anything with K1.
Why
Equation.
am I looking at it? I like.
Oh, you just.
And for the, what do we do with the second
Oh, I
equation
know
there?
how to do it.
We need 4 NOs to cancel out, so I need to multiply that second one by 2, it looks like, for the NOs to cancel out. And then it's going to add 2 more O2s to the 5, which is going to make 7. Are you with me? So you have to multiply the O2 by 2, or the second reaction by 2.
So it'd be like being. Oh, we don't.
What's that?
The thing I don't get is like, yeah, you multiply the reaction by 2, but then you're like, for the K, you, like, yeah, I got the squares.
Whatever the change was, you apply that change to the exponent on K. Yes. So if you turn it around, it's like multiplying by -1, K gets raised to the -1 power.
So this is like Hess's law, but with exponents.
Yes, with exponents rather than multiplying. Yes.
But we still keep the multiplying here, you know, we don't like, you know.
Yes, if you multiply it through a 2 through the equation, you multiply that, but the K gets raised to the second power. It squares the K. Yep. You have to get used to that.
Wait, so how would you know when to divide them?
Oh, because you're always going to know what the final reaction is. That's what you're trying to get to. That's your target reaction. So you have to manipulate those 2 that they give you to get that last one.
Wait, the answer is here.
Which is the answer? B. You have to multiply. When you're adding those 2 equations together, you multiply the K's. And equation number 2 got multiplied by 2, so its K got squared. We good?
Yeah. Next question.
All right, now that was number 4. Just one last topic, really, and that is, you'll notice that some of these problems, they had a KC, a K with a little subscript C. What's that doing there? I'll tell you what it's doing there. There's 2 different ways that you can express an equilibrium constant. Kc is when you take the ratio of the concentrations. You can also use Kp, which is the first one we learned, the ratio of the pressures. Are they the same?
Yes.
You wish they were, but they're not. Anna?
On the AP Chem test, will it say KC and KP?
Yes, it will. And often they will ask you about the relationship between Kc and Kp. So this is one we have to know and know well. What? Yes.
I think I know where we're going with this.
Yes. Yes. Sorry. All right. So here's a chemical equation of a reaction, the production of ammonia from nitrogen and hydrogen. The Kc is the ratio of the concentration of products over reactants. So, you know, we use the brackets there for molarity. That's the concentration ratio. The Kp is the pressure ratio. Pressure of products over pressure of reactants. On the AP exam, in the free response part, there's 7 clusters of questions on the free response part. I guarantee that one of those big clusters is going to be an equilibrium cluster, where they'll ask, now remember, we're going to do 4 chapters on equilibrium. It's not necessarily going to be a cluster out of this chapter, but there's going to be a heavy emphasis on equilibrium on the AP exam. I mean, what is it? We're taking 2 full months of equilibrium. That's a quarter of our curriculum in this class is just equilibrium topics, so you can guarantee that, be guaranteed that a good sized chunk of the AP exam is equilibrium. Yep. Yes, ma'am?
Why does it say Kc equals K equals?
Yes, thank you. When you just see a K and it doesn't have a subscript after it, it means Kc. The Zoom dolls will do that a lot. They'll say, find Kp and K. And they mean this one when they say K. I know, they're so good.
There's so many K's around.
I hate that.
Oh yeah, we're just adding to your K repertoire.
So annoying.
The long list of Ks.
So what's the difference? I mean,
Really, because there's so many K's in it. Yep, yep. You should make a motion to do that. Good luck. Have fun with that. All right.
Mr. Redford, getting back to PV.
My friends, whenever I tell you that there's a relationship between 2 things, do you know what that means is coming?
Graphs.
That means a derivation is coming.
Oh,
Same thing.
fun.
Why?
Does this involve
I need to send
PV?
you off to your break with a derivation. I just feel like it's needed.
This feels like running
Mr.
on break.
And I have to tell you, and this is totally from the heart, you may groan when I say that I'm going to derive something. And you may think, oh gosh, here we go again. But you are going to see the benefit down the road. When you're in college and you need to, you have to take science classes, many of you are going to go into science programs, you are going to be at such an advantage knowing how to derive stuff. Now, I don't ask you to derive anything, do I? I just show you how to do it. And you can still complain. Just wait. There will be times when you are required to derive something, and when you're at college, you'll be able to go right through it. Your professors will expect you to be able to do that, and your peers are going to be pulling their hair out because they have no experience with it. And they're going to be like, I don't understand how you do this. Oh yeah, well, you just derive it.
Technically,
So Robbie,
Does the derivation involve anything to do with PV equals energy?
what? Anything to do with what?
PV equals
Wait,
energy. Does it? Just wondering.
No,
I knew it. I knew
Chinook,
it.
So, you're saying, okay.
Chinook, were you mad when I called on her first?
Yeah.
She had her hand up for like 5 minutes, and you just want to spout something off, and you get mad when I call on her.
Okay, fine, we'll just move on.
No, no,
It's
Chinook asked.
irrelevant. It's irrelevant.
It was about
Yes,
driving.
It's up to you. If you just want to observe, it's fine.
Wait,
I'm going to have an equation for you at the end that relates the two, and I'm just showing you how we did it.
wait, what's with the white? Actually,
Yeah.
I can't see them.
All right, now what does the white say? You know what this thing says.
Uh-huh.
I love that equation.
I know that.
Background.
I think that you do too.
It's like, I keep finding
PV equals nRT. If I divide out the V, let's go ahead and do that.
I get it now.
It's red for you, Artea. So the V's cancel out there. V. So now nRT over V is the same thing as N over VRT. Yeah?
Sure.
Yeah. It doesn't matter what order you multiply and divide in.
And then you do P1, and then off.
Yes,
and
now
R
hold
don't
on, wait,
matter.
nope, time out.
Okay.
What is the unit on N over V?
Molarity.
Molarity.
Moles over liters? Molarity. Right. So this thing right here is really molarity.
Do we have to?
And I just want you to know that molarity is the same thing as P over RT. If I use that for molarity and divide out the RT, molarity is P over RT. Yes, ma'am?
Like, you talked about polarity a lot. Will we ever get to molality?
Never.
That's
We
one.
used to have to do molality. We have been able to cut an entire chapter out of this curriculum because just 2 years ago, the College Board said they were taking out all the things about colligative properties, which is what molality uses. And so you don't have to know that, and we have taken out that chapter. I know.
I'm down
So it's
mine.
sad. You kind of get ripped off, where 2 years ago they learned more than you did, than you're doing.
But we learned molality last
Yes,
year.
our chance.
Are we able to learn about energy levels?
I missed it
Are
about.
we gonna learn about energy levels?
Oh, yes.
No.
I can almost tell you the date on that. Energy levels. It's going to be about early the first week of April.
We want energy level.
Like it has to be two.
When we're not on
I thought
vacation, that
we
is.
learned that
No,
already.
like
That was like the first reading quizzes.
no, it's like more.
I didn't know.
Which spring break was in April.
Moles
Right?
of solute over kilograms of salt.
I'm from Canada. It was in March.
All right. Now we have to move on. I think it sounds like you're having some stall tactics going on here. Avoiding the derivation, Lena?
I actually
Always.
enjoy the derivation.
So now we know the molarity is P over RT. You got that part? Remember, we're still working on this equation. This is my equation that, and the reason that I'm doing that is because it's got a couple of things. They're all gases, so we can use pressures and concentrations. And the coefficients are not all ones. We can see how the coefficients are affecting this relationship, because they do. Okay, so I'm going to rewrite the chemical equation. It was N2 plus 3H2 yields 2 NH3. And now I have my Kc expression. It's the concentration of that over the concentration of that. We have now a new name for molarity, though, and that name is P over RT. Yes, from the good old ideal gas law, the granddaddy of them all.
I thought that was K values.
Thought what?
Never mind, too large.
Okay, thank you. So this thing right here, I'm going to replace, and this is where it's going to get good. P over RT of NH3 squared over P over RT of N2 to the first times P over RT of hydrogen cubed.
I
How do
see
you
where this
expect
is
us to do
going.
that without like a calculator?
I haven't touched a calculator.
But there's no numbers, so I mean.
Oh, well, let's keep going. Can we clean this thing up? I think so. I see some terms that look
Yeah,
like.
we cancel them out.
Yeah, and some RTs cancel out too. All right, now what I'm going to do strategically is I'm going to pull all the changing variable terms kind of off to the side and then the constant terms next to it. What's changing here? The pressures change. The R and T, though, they're constant because we assume that the R and T are the same for all of these. Okay? I'm going to try green. Tell me if you can't read this one. So Kc equals, ooh, I don't want to show you that. Kc equals, and it's still the Kc, that would be the pressure of NH3 squared over the pressure of N2 times the pressure of H2 cubed. Times, so I've just pulled out this, this, and this. Now we still have the RTs, and that's the only thing that's left. Now what does it look like? Oh gosh.
RT.
1 over RT.
RT.
and then divided
So
by
yeah, it's 1 over
4.
RT squared over 1 over RT to the what power?
4.
4.
You got 4 RTs in the bottom. You see that? Now these RTs are in the denominator of the denominator. Yes?
So
They flip
RT
up to the
of
numerator.
4
So
equals-
it's going to look like this. It's times RT to the 4th over RT squared.
Oh, so you can.
Now
reduce
there's a reason
those
I haven't
RTs
canceled
so-
anything yet. What is this thing right here?
thing that we learned last
This is the ratio of the pressures, isn't it? Also known as
KP.
KP.
Wow. But we still have to do all that. So
There was no point of doing that.
Totally there was.
We were trying to find the relationship between that.
Okay, now what about this RT? Now I know that we can cancel two of the RTs out and just make RT squared. But can we generalize this simplification? Is there something that you can identify is the source of the 4 and the 2? And where did those exponents come from? Yes? And those are the coefficients from the equation. What does the 4 signify?
The number
Nick?
of
The coefficients of the reactants, 1 and 3 there makes the 4. The 2 is the coefficients of the products. So really, this, we're going to have RT to the 4 minus 2. It's the reactants minus the products. Reactants? When do we ever use reactants minus products? Never. Here's what I'm going to do. Yes?
So are we gonna ever have a problem where you're like given KC and then the equation, then you have to find KP?
Yes, I am.
Oh,
He
fun.
loves tutorials.
Well, I'm not going to do it. The Zoom dolls are going to do it.
Oh, okay, gotcha.
But it's only for your good. So here we go. KC equals, now we're going to rename this whole thing KP. And then it's going to be times RT. And again, how can we generalize this thing? It was the coefficients of that minus the coefficients of that. I'm going to do it like this, and I want you to pay attention, see if you can catch it. I'm going to call it to the power of negative delta N of gas.
That is
Delta N is the change in the moles, and it is
negative cos.
2 minus 4 is negative 2, but we took the negative of that, and that's why we got 2.
you're confused. Wait, again.
Remember how it was RT to the 4th power because there were 4 reactants, divided by RT to the 2nd power because there were 2 products? So you can simplify this by keeping the RT and subtracting 4 minus 2.
Yeah.
It's reactants minus products, which is like the opposite of delta N. Delta N would be products minus reactants.
Alright.
So I'm calling it to the negative delta N power. Because negative delta N would be reactants minus products.
But then we have 4 minus 2 there, which means that like we disregard the negative because that's just like
Well, what is delta N? Delta N is 2 minus 4. It's negative 2.
But then
But we need positive 2, so you take the negative of them. It works.
yeah, but when you put the RT forth when
Because you keep the RT and you subtract the exponents. But you have to subtract reactants minus products. What?
That's a positive 2, which means that you know like
You're taking reactants minus products,
oh we never mind.
which is the opposite of delta N.
Yep.
So we call it negative delta N.
Got it.
All right, now, what does it look like here when you have RT to a negative power? RT really is in the denominator with that delta N power, right? How about if we solve it for KP? So right now we have this. We have KC equals KP over RT to the delta N gas power. If I solve it for KP, you're going to have to multiply both sides by that RT delta N, right? And it looks like this. In general, KP, so we normally will solve for KP. So I've had KP kind of in the middle of this thing the whole time. Now I'm just getting that by itself. I'm taking that RT to the delta N and moving it over to the other side. So it's KP equals KC times RT to the delta N of gas.
Wait, where did the 0.82?
Okay, now I'll answer that in a second. Don't get confused about that. Just be open-minded. I want you right now to be able to come up with an understanding of this. Write it down. Lena? It's 821. I'll tell you why in a second. Don't do that. I've warned you about my memory. Not warned you, I guess, but I've enlightened you about my memory and how terrible it is. And I really do mean that. I tell you that every time. I'm not just joking about having a bad memory. I stink at memorizing stuff. So when I have this equation, I have a horrible time knowing if the KC goes there or the KP goes there. Can you see how that would get confusing? Are we solving for KP or are we solving for KC? Short of deriving the whole thing, how do we just memorize this equation? PC. Right. Think of it, oh my gosh, this is so complicated, I would need a PC to figure it out. Or this is a politically correct expression.
Wow.
PC. Whatever it takes to remember. Yes? What does that mean? It's the difference in the coefficients.
Why is it 0.08?
What do you ask? Hold on a second, I'll get to that. Shree, what are you asking me?
What is delta L and
Oh, the difference in the coefficients. The change in the number of moles of gas. So we have 2 moles of gas minus 4 moles of gas. That's what goes there.
Oh, okay.
All right? Yes, ma'am?
Isn't it supposed to be KC over RT negative delta L? 'Cause like,
From this thing, I wrote this. Okay? Because the RT is raised to a negative power, which means it goes in the denominator. And then I solved for the KP. So I took this term and multiplied it by that over there. Okay?
You could also do pandas are cute.
Pandas are cute. Pandas are cute. Yep.
Yeah, too.
They are. This
But don't call it the cute panda expression.
no, no. Confused me.
Okay. Now here's the other thing. Everybody's looking at this thing and saying, "Hold on a second. This is not the right R." It is the right R, and here's why. You know, back to our good friend.
And there's a
Oops. This thing right here,
Yeah.
and the K expression has pressure over pressure. When you use KP, the pressure must be in atmospheres.
Yeah, the 0.
Write that down for yourself. Using KP, pressure must be in atmospheres.
Oh.
So if you're given pressures that aren't in atmospheres, you need to convert before you find KP. It's got to be in atmospheres. What is R when your pressure unit is atmospheres?
0.00827.
No, just 1, 0.
I think
Wait.
there were 2.
Isn't there 2?
I swear there were 2.
I normally use only 3 sig fig, so I call it 0.0821.
and there's another R.
It's like the same thing as
Shelby,
That's
Can-
why
Shelby,
you
can
have
you
to
go
use
to my
that
bag and
value
get
of
my
R
calculator?
for those
It's in the
problems.
front pouch.
There are so many
Calculator?
R's,
Yeah.
so many,
I have a, no, like, I have my calculator. I have
I feel like
everything
there's so many
saved.
letters on the alphabet. Like, they should invent new
Front
letters.
pouch. Frontier pouch. That pouch, yeah.
Maybe. All right, my friends. Oh, just before I'm done now, but I did want to show you this.
I swear there were 2.
The homework problems, the ones that you'll be. Hey, hi there.
It's only.
We're just working
there's
on some
only one
equilibrium,
zero.
Belino. Come on
So-
in, you can try some. The first exercise that we have is number 24. It's the first assigned one. And we have a given KP. Oh, let me just take a freeze this so it doesn't fall out.
Yep, 4 minutes.
You're given, no, we're not going to do this. I just want you to see what the problems look like. You're asking if we can do some of them soon. And yes, you're given KP. You have this equation. And so what happens if you turn the equation around and divide by 2? What do you do with the K value? We can learn how to do that now.
The 1 over the 6.
1 over the square root of it. Right. And then what if we just turn it around and don't divide by 2? And so what is the K if we manipulate the equation like that? And then later on, and these I know are assigned too. Which one of them is? Numbers 34 and 35. Well, let's just take a look. Number 33, write expressions for K and KP. That's like what I was talking about where one of them is KC and the other is KP, but KC is also known as just K. In which of these, there's one of these four in which KP would equal K? Which one? That's what number 35 is asking. In which one is KP equal to K?
We don't know.
Do you want to see? We don't know.
You don't have to write anything, just look.
Is it D?
Yes?
Is it D? Oh, cool.
It is D. How do you know?
That's a 2 to 2 ratio.
Nope.
1 to 1.
Oh, what? Well, yeah. Well, it's.
Well, yeah, what? What's the well, yeah part?
Yeah. They both have
No solid. Remember, that's why I had delta N gas. It's 1 mole of gas being produced from 1 mole of gas. So your delta N of gas is 0. RT to the 0 power means that Kp equals Kc.
Oh, you only look at gases?
Only gases.
That's even.
No.
So if the delta ratio is 1, then
Delta means change. Products minus reactants. You said delta N ratio. Ugh, you got too many terms in there. If the delta N is 0, then Kp equals Kc. Artea? Yes, I was going to. All right, so let's look at A. What would the delta N of gas be? This is producing, that's a solid, 1 mole of gas is produced from 3 moles of gas. 2 there and 1 there. So the delta N of gas in this one would be -2. You got 3 moles of gas changing to 1 mole of gas. This thing does not count in the equilibrium because it's a solid. The only thing that counts in equilibrium is aqueous and gases. So that is ignored. So your delta N of gas is 1 minus 3, which is -2. In B, your delta N of gas is what? You got 1 there and 3 there. 4 minus 0. So its delta N is 4. You started with 0 moles of gas, you made 4, so your delta N is 4. Yep. In D, this is the only one in which it makes 1 mole of gas from 1 mole of gas. The delta N is 0. So the RT is going to be raised to the 0 power here, and then these two are equal to each other. They don't like chemistry?
They're actually going to JB. Another chemistry teacher. I think they like it more. I'm sorry.
Oh!
No, they had JB.
Yeah, I'm just kidding. So that's what we're doing there with the delta N. We'll take that up tomorrow if that doesn't make sense. Try those though. Look at the solution guide and see what it looks like.